Welcome to part 2 of derivatives of exponential functions. In part 1 we learned how to find the derivative of e to the x. We learned that the derivative of e to the x is e to the x. And in this video we're going to consider other exponential functions. Exponential functions where the base is not number e. And then we're going to solve 3 examples of derivatives with exponential functions. So in part 1 we show that the derivative of e to the x is e to the x. Now we're going to consider other exponential functions. We're going to consider the exponential function f of x equals h dx. This is an exponential function with base a. And we want to find its derivative. And to do that, we're going to use the same strategy we used in part 1. We're going to take the natural log of both sides of the equation, and we will have that the natural log of f of x equals the natural log of a to the x. But the natural log of a to the x equals x times the natural log of a. And now we're going to take the derivative of both sides, and on the left we're going to have the derivative of the natural log is 1 over what is inside, in this case is f of x, times the derivative of the inner function, and that will be f prime of x. And this equals the derivative of the right side. Here the natural log is a constant, so this derivative will be just the natural log of a. So we have this equation, and here we can solve for f prime of x. If we multiply both sides by f of x, we have that f prime of x equals f of x times the natural log of a. But hey, f of x is a to the x. So we have that the derivative of a to the x equals a to the x times the natural log of a. And this makes sense because in part 1 we saw that the derivative of e to the x is e to the x. If here we put a equals e, we're going to have e to the x times the natural log of e, and the natural log of e is 1. So this makes sense. It agrees with what we saw in part 1. And now we're going to solve some examples. Let's consider this function f of x equals a to the x squared. And here we need to apply the chain rule to find its derivative. We're going to have that f prime of x equals the derivative of the outer function, that is the exponential function. And it will be a to the x squared times the natural log of a. And now we multiply by the derivative of the inner function. The inner function is x squared. So we multiply by 2x. We can write the answer like this, and that's the answer. Now let's consider this function. We have 7 to the x squared plus 2x. We take the derivative. We're going to use the chain rule again. We have the derivative of the exponential function, that is 7, that is the same function times the natural log of 7. And we multiply by the derivative of the inner function, that will be 2x plus 2. We can factor the number 2 here, and this is the answer. Now here we have a more interesting example. This we can see this as the product of two functions. We can consider that e to the x is e of x, and that the natural log of sine of x is v of x. So we're going to use the product rule. We apply the product rule. Here we have that e to the x is u prime of x, and the natural log of sine of x is v of x, plus e to the x. E to the x is just u of x, and we multiply now by the derivative of this function, that will be 1 over sine of x times cosine of x. Here e to the x is e of x, and this factor is b prime of x. And here we just factor the e to the x, and we get the answer. So that's all for now. Thank you for watching, and see you next time.